So today we will be solving the third problem of today's biweekly contest, design an ATM machine. This question is quite simple. Uh, there is an interesting follow-up of this question which we will be discussing as well. So after discussing the actual solution, we will be jumping over to a interesting follow-up of this question and solve that as well. So stay tuned till the very end. So let's start. The question states that there is an ATM machine that stores bank notes of five denominations. So there are total five kinds of notes stored in the ATM machine. Uh, the values of them are 20, 50, 100, 200, and $500. Now, when withdrawing, the machine prioritizes the bank notes of larger values. So basically, when you have to withdraw, let's say you have to withdraw 600 rupees. So if you have to withdraw 600 rupees, then machine will try to give you 500 rupees if available, like one 500 rupees note if available. So that's what the problem is. Basically, you have to just implement two function, deposit and withdraw. Deposit will just say you are depositing some money. You will just give the number of notes of each denomination that you will be depositing. And for withdraw, you will be just specifying how many money you want to withdraw. And for each withdraw, you have to return exactly the count of each notes that you will be getting when you are withdrawing from the ATM. So that's what the problem is. Let's try to understand this with an example. So there is one important statement in the problem. Basically, um, this constraint. So what it says is, let's say the bank contains three $200 banknote, three $200 note, and one $500 note, and you are trying to withdraw $600. So in this case, you can see with three $200 you can make $600. But if you remember, it was said that bank will try to give you the max denomination note if possible. So it will try to give you $500, and after giving $500, it will see that okay, I don't have $100 note. So in that case, it will just reject your request and not give you any and not give you any note, and will just say that it doesn't have enough notes to give you. Notice again, there are $600 in the bank, because in the ATM, because there are three notes of $200 available. So but because of the policy that it should, the ATM should start with the largest denominations, and after giving the largest denomination, what happened here is we don't have a note of $100, so that's where it is rejecting the request. So hope this constraint is clear. Now let's try to look at an example to just clarify it a bit. So let's say this is the state of the ATM. Basically, currently ATM has one $100 note, three $200 note, and one $500 note. Now a withdraw request come for $100. So it will just withdraw this, and the new number of note in the ATM is left is 0, and this request will be fulfilled. Now again a request come for withdraw 600. Now notice there are $200 note which can which can make up to 600, but because of this policy, we will start with 500, and we will see that okay, after giving 500 I want 100, and 100 is not possible with any of these. So that's where this reject will simply be rejected. So this request will simply be rejected. Now the third is deposit 100. So here basically the request comes to deposit $100 rupee, 1 rupee of $100 note. So basically this will be increased by one. Now the second, and then the request come to withdraw of 600. So this time we will the bank will give you 600, basically uh, give you one 500 note and one 100 note, and will give you 600, and the state of the ATM is this after serving this request. So that's what the question is. Hope the question is clear. Now what about solution? So with this constraint, right, like when it is saying that you have to start with the largest node, and then go on with the next smaller notes. The question is like we have to just perform exactly what the question states. So for the deposit request is very straightforward. You will just maintain an array of each of these denominations, and you will increase the corresponding denominations. Uh, the withdraw request, you will start with the largest, try to give the largest as much as you can, and then you will start the second largest, try to give it, then this, then that, and then after everything, if you see that you still have something left to be given, then you will just say that okay, you can't give anything. But if you don't have anything to be give, like if the amount that is required after processing until this is 0, you will say that okay, I can give the requested amount and will return the corresponding denominations. So the sample pseudocode would look something like this. So you can see here that here where we are withdrawing X, and the withdraw request, we will first try to withdraw $500 note, as much $500 notes as we can, and decrement the the required amount by 500. We will keep on doing this until we can give 500 notes. Remember the constraint again. Then we will keep on doing this until we can give 200 notes. Then we will keep on doing this part until we can give 100 rupee note. Then we will keep on doing this part until we can give 50 rupee notes, and so on and so forth. Now after giving each denominations, if you see that there is still something to be given, you will just say that it is not possible to give. It is not possible to withdraw this X amount from the ATM. Otherwise, you already know the counts, so you have decremented this counts, right? So just add one more variable that will denote the count of each of these kinds. Now, once you have count of each of these kinds, you will just return them as a vector from here. So this is the solution. This solution would work, but there is a catch here. If you see the total amount that can be requested for withdrawal is 10 to the power 9. Now, because total amount that can be requested for withdrawal is 10 to the power 9, how many times do you think this loop will run? Let's say you have infinite number of 500 rupees note. So how many times this loop will run? This loop will run for until you uh, just finish giving this 10 to the power 9 value. Basically, you will first give 500 rupee note, and then this will become minus 500, and then again give 500, this will again give minus 500, and so on and so forth. You will keep on uh, giving 500 notes until you exhaust the 10 to the power 9. So in worst case, uh, this one loop can go up to 10 to the power 9 by 500. Okay, so which is approximately equals to 10 to the power 6, let's say. Okay, so for each loop, like for each withdrawal request, you are performing 10 to the power 6 number of iterations. So and there can be 5,000 withdrawals request, right? So that basically into 5,000. So this will not fit in time limit. So that's where this solution will not fit in the time limit. Now if you look at this, you have to like the actual solution is this only. Like you have to perform all these steps, because that's what question is asking you to do. But uh, you don't want to perform these things incrementally. So just see if you can, instead of this while loop, if you can have a single statement here. So that is possible. Let's say you have to withdraw. Uh, let's say you have 200 rupee note, uh, or maybe let's say you have a 10 200 rupee note, and you have to withdraw, let's say uh, maybe 900. Okay, you have to withdraw 900. So now how many 200 rupee note can you give? Assuming that there is no 500 rupee note, so we will start with 200. So how many 200 rupee note you can give for 900 withdrawal? that is equals to 900 by 200, right? This many 200 rupee note you can give at max for 900 withdrawal, right? So it will come 4, like the actual is 4.5, but because you can't give half note, that's where you will just take the floor, and you can give at most 4 notes of 200 in case you have to withdraw 900 rupee note. So or 900 rupee denomination. So basically, you have this loop can go at max 4 times. That's what you have determined with this division. So once you have the value that how many times this loop can go, you can just simply apply that instead of doing this while loop, and that will just bring down that will just bring down this entire while loop to an if condition. So this, if you remember, there were 10 to the power 6 iterations because of this while loop itself, and we have just removed the 10 to the power 10 to the power 6 iterations, and so the time complexity would be order of one per withdrawal. So let's look at the code. The code is simple. We have two arrays, count and value. Value denotes the denominations, and count denotes the count of nodes of each denominations. So we have to deposit these counts, this many bank like count this many nodes of each denominations. We will just increment the corresponding counts. Now, when the withdrawal request come, we will try with the highest denomination. So remember that our highest denomination is the last. So that's why I'm starting with 4. So we'll try with the largest denominations, go until the smaller denomination. If the value of the denomination is greater than is less than the amount, basically we can give some notes of this value or not. If that is possible, then we can calculate how many we can give. So basically, if we have to if the amount is 900 and we are at 200 rupee note, then we will calculate that, okay, I can give four notes of 200, right? So that's what it is being calculated. So 4 notes of 200 can be given. Sorry. So 4 notes of 200 can be given. Now we will check whether we have 4 notes or not. So if we have 4 notes, we like this CNTG denotes the number of nodes that we have. So if we do have 4 nodes, we will just give those 4 nodes at once. If we don't have 4 nodes, we will try to give, basically we have less than 4 nodes, so we will try to give as many nodes as possible, right? So that's where we will just give whatever nodes that we have, total number of nodes that we have. Now based on whatever we have given, we will decrease the amount by that. So we have given this result j number of nodes of type denominations val j, so we will just decrement the amount by that. So after giving all this one by one, if we see that amount is still not 0, we still have some amount to be given, we will just return -1 because it is not possible at all. If amount is 0, in that case, remember, like notice that we haven't modified this count array at all. Like here we have just modified this result array. So count array is still not modified. Now we will just modify the count array. Whatever we have stored in result, we will just modify count array accordingly and return the result. The result contains the denominations of each type. So hope the problem is clear. If you have any doubts for this question, please post them in the comment section below. I will address them. Now let's look at the interesting follow-up of this question. So as we have discussed, like we will be solving an interesting follow-up. If you remember, the question states that the ATM, if ATM has three 200 bottle 300 uh, three 200 rupee notes and one 500 rupee note, it can't serve a request of withdrawal request of 600 rupee note 600 rupee value, because previously it was given that it should start with, if it has greater denomination, it should start with that denomination. If it is not possible to give that denomination, then ignore that request altogether. But here we are saying that if it is like, even if giving, we will try to give the max, and if it is not possible, we will not ignore it if we have denominations of if we can serve this request, we will serve the request with lower denominations. So for example, here we have three 200 rupee note which will combine up to $600. So we will just serve the request with by giving this 200 rupee note. Notice we still have 500 rupee note, but we are not giving it because giving 500 rupee note will not serve this request at all. So again, for example, let's say first a withdrawal request come for rupees 100 or for $100. We will serve this, and this will become like this will be the new state of the ATM. Then a withdrawal request of 600 come. Previously, we were not able to serve the request, if you remember. But now this time we will be able to serve the request, and we will give three $200 note. So the new state of the bank is this, and we are able to serve this request. Okay. Now again the deposit of 100 come. So this will be one. Now withdrawal request of 600 come. Again this is possible now with this one 500 and one 100 note. So the new state of the bank will be 0 and 0, and this request can be satisfied. So hope the follow-up question is clear. What we are just doing is we are just relaxing the constraint that we are given in the original question. So now how to solve this? So basically what you are doing is you are trying to see if you can uh, serve the request. Like again, the deposit request is very similar. We don't have any issues with the deposit request. What we are only dealing with is the withdraw request, whether we are able to withdraw some particular denominations or not. So as with every question, let's try to first see whether we can give 500 rupee note or not. So let's say the denomination requested, like the withdraw request for rupees X or dollar X comes. Okay, so what you will do? So let's try to first start with $500. So what will happen with $500? Either you can give, first of all, how many $500 rupee note can be given at max? That is X by 500, right? This many number of 500 rupee note can be given at max. Okay. Now, uh, will eh, will you be giving this five, like what you can do? You can either give 0 500 rupee note, you can give one, you can give two. Let's say the value comes three. So what you can do is you can either give 0 500 rupee note, you can either or give one 500 rupee note, or two 500 rupee note, or three 500 rupee note, right? So that are the possible combinations for giving out this 500 rupee note. So once you have given one of these combinations, you will be left with some amount, right? So basically previously, let's say the amount was X. So now if you have given two 500 rupee note, amount will be X minus 1000. If you have given three 500 rupee note, amount will be X minus 1500, right? So basically let's denote this new amount with AMT. Now what you're doing is you have just reduced the problem. Previously you have these five denominations to handle, but now you have said that whatever you can do with 500 denomination you have already done. You can have served at max three nodes. So you have tried serving all possible solutions, like serving 0 1 2 3, whatever you can serve. You have served this 500 rupee note, and now you will be not going to touch this 500 rupee note. What you are left with is some amount, and now you will starting with 200 rupee note. So what you have done is basically reduce the problem into a sub problem of same kind. Previously we have to serve the request of withdrawal of X dollar from using the denominations of this kind, but now we have to serve the request of withdrawal of this amount using using only these denominations. 500 is not there. So hope you can see the recursion here. So now as soon as you can see the recursion here, we can just write the recursive formula here. So the recursive formula would look something like this. So as discussed, we can do two things. So f of amount of last node index, basically last node index denotes the uh, this index. Basically if the index is this, you can use 500. If the index is this, you can use at max 200 and so on. So last node index denotes that. Now what this function denotes is basically if how many minimum nodes require to serve this amount using all the denominations until here. So that's what f our function is. So f of amount of last index, as discussed, we can either give 500 denomination, 0, 1, 2, 3. Like either we can worry about this, or we can simply say that okay, I will not give 500 and just start with 200. So basically, initially we decided not to give anything. So uh, we have decided not to take this 500 or last note index, and we just say that okay, now just make the same amount with all the denomination which are lesser than this. Or we can do what we can do, we can take one 500. If amount allows us, we can take one 500, and uh, we can say that okay, like see, you can do two things. Either you can calculate this x by 500, or you can say that okay, I will take one 500 and let the next iteration take care about taking one more 500. Okay, so that's where what we have said, what we have done is we have just taken one 500 here, and we are saying that okay, let's not worry about how many 500s we will take. We will just say that okay, from next time onwards, try with 500. Try, you can give 500 or anything less than 500. So if next iteration they don't want to give 500, you will just come with this and skip giving 500. So hope this function makes sense. You can just memorize it to make it to avoid recomputing the same state again and again. I am not showing you the code of this question because after you have solved this f, you have to also write a function which will give you the actual denominations. Notice the answer denotes answer demand you the actual denomination. So this is the array that you have to give return as the answer. So with this function you will just return the count of nodes, not the actual denomination. So you have to just with this you have to just maintain another array for that. I have discussed the same kind of technique before as well. It is very similar to standard DP techniques, wherein you are trying to, you get the actual value, but you also want to find the exact sequence by which you reach here. So you can watch. I will link one of the videos in description below. You can watch that, or you can read any of the articles. It's a very standard technique. Basically, you have the count. What you want is how did you get the count? Basically, how many last node index you have used, how many last node index minus one you have used, last node minus two you have used, and so on. So just try to code it. I will encourage you to code this solution. And as always, feel free to paste your code in the comment section below. I will definitely review it and tell you if there's any issue with your code or if it's correct or not. So that's the end of this video. If you like the video, do give us a thumbs up, and subscribe to the channel if you haven't already. I am regularly posting videos about interview experiences and other things in this channel, and all not only that, I also try to post as many follow-ups as I can for the lead code question that I have solving. So do check them out. I will link them in the description below. So until tomorrow, goodbye.